Hi guys. So here, as you guys can see, we have programmed our Fpga. So here, our 7/7,0 LEDs blinking, and let's look at the code now. So here we will focus on the assign LED count 24. So I have opened the calculations over here. So if we look at the clock and counter math, so over here, as you can see, our clock is like 50 megahertz, and if we divide the clock divided by 2 raised to the power n, so that gives us like 2.9802. So that basically means that that's about 3 blinks per second. So in this way we can manage the blinks of this LED. If we want to higher or lower, we can just basically change the value of count, and then by dividing that, by using that formula, we can actually look through what would be the number of blinks that we get per second. So this is how basically the blinking of LED with one LED is working out. So now, as we can look in our code, so now we change the value from assign LED. So now we can see the count value is 5, and here now we can look at the changes of our FPGA board. So now initially we guys observed that this LED was blinking, so it was like probably in 4 blinks per second, but now as we have given it a small value, now it's not blinking anymore because we have provided a significantly small value. So here we can say it's just like it's just not blinking anymore. So that's the main reason, because we have given it the small value. So the count is 5. So here we can see like our code is all compiled up. So in order to make this happen, we firstly once again compiled our code. Once we were done with the compiling, so after we done with the compiling, we uploaded the saved code over here. So in order to do that, we just basically did the change file, and then we grabbed it blink.sof from our output, and then we ticked this one off and basically just uploaded the code to over here. So here we can see the progress is 100%. So this is basically how you can achieve different blinking rates on LEDs. So that's how you do it. So now we have used all the 8 LEDs in this FPGA. So now let's look at the code over here. So over here, as you guys can see in the code, we have output wire 7 semicolon 0. So this basically means like we are going to use an array of 8 LEDs, and over here input clock is a 50 megahertz input clock. So now we need to focus on the assign LED. So count is 28 semicolon 21. So that's the one which is so in this one we basically saying that every LED is going to run at different bits, so it's gonna be blinking at different time. So that's how we do it. So basically we just so in order to compile the code, we went to assessment, and then we went to sorry, not this one, and then for this one we went to assessments, and then we went to pin planner. And over here in the pin planner, as you can see over here, we have assigned all the pins to the pin planners that was given to us in the document. So we, according to that, we followed that process, and we have assigned all the LEDs to one pin. Like for LED 7, we have assigned pin AA23, so that's an output pin, and that's how we allocated the pin. So after we were done with the allocation, what we did was, and after we did the allocation, we basically just compiled the designs, and over here we can see all the design was successfully compiled, all the time analysis and all the stuff were ticked out. So once everything was ticked out, we went to the programming device. So over here in the programming device, we uploaded the new output, the new code that we have written, like the blink.sof. We uploaded this one over here, and then we just clicked on start, and here we can see like our progress is 100%. So once the code was successfully done and uploaded to the FPGA, here is the required result. Here we can see all the 8 LEDs are blinking at different time rates. So that's how we were able to blink all the 8 LEDs. We can use the same method and we can blink other LEDs as well. We can increase or decrease the blinking rate. So that's the basic idea behind this process, how this is done. I hope this was helpful. Thank you and have a nice day.